Hello and welcome to another Algebra 2 lesson by eMath Instruction. My name is Kirk Weiler and today we'll be doing Unit 4, Lesson 3 on exponential function basics. This entire unit is about exponential functions, and so far we've kind of set you up with a discussion about both basic exponent laws and fractional exponents. And I hope that you've had a chance to see both of those videos, or you've at least been exposed to both of those topics in your math class before we begin what we're going to do today. Anyhow, let's jump right in it and review some things about exponential functions. In Algebra 1, you extensively studied exponential functions. These are functions where the base is constant and the exponent is a variable. Their general form is as follows. An exponential function has the form y equals a times b to the x, where a and b are positive real numbers. The number b is known as the base of the function. All right, and the way I kind of want you to think about this is almost like a linear function, y equals mx plus b, where you keep adding the quantity x to the number b m times. Here, on the other hand, you're taking the number a and you're repeatedly multiplying it by the number b x times. That's of course assuming that x is a positive number. If x was a negative number, then you might be dividing the number a by the number b. Anyhow, let's get into exercise number 1. An exponential function is defined by the equation f of x equals 8 times 2 to the x. Determine the y-intercept of this function algebraically. Show the work that leads to your answer. What does this tell you about the y-intercept of y equals a times b to the x? All right, well, there's quite a bit in letter A. What I'd like you to do is pause the video right now and see if you can do the entire part of the question, but if you can't do that, at least just figure out what the y-intercept of that function is. Well, as always, the y-intercept of any function is the output of the function when the input is x equals 0. So for our specific function, f of x equals 8 times 2 to the x, right? F of 0 is 8 times 2 raised to the 0. As we discussed in an earlier lesson, any number raised to the 0 power is equal to 1, and therefore the y-intercept is equal to 8. All right, now, more specifically, or more importantly, what does this tell you about the y-intercept of y equals a times b to the x? Well, we could do this one as well, right? We would have a times b to the 0, which would be a times 1, which would just be a. So a is the y-intercept, which I know is a little bit confusing because when we have y equals mx plus b, the b is the y-intercept. But in an exponential function, what we always want to kind of think about is we are starting with this number, right? That is our y-intercept, our starting value. And then as x increases, we are multiplying it repeatedly by 2, or as x decreases, we are repeatedly dividing it by 2. All right, let's take a look at letter B. Calculate the following without the use of your calculator: f of 1, f of 2, and f of 3. All right, why don't you go ahead and do that? With this function, figure out f of 1, f of 2, and f of 3. All right, and again, think about what I've been talking about, right? We're starting with the number 8. F of 1 basically says, hey, multiply 8 by 2 once. F of 2, multiply 8 by 2 twice. F of 3, multiply 8 by 2 3 times. So f of 1 is 8 times 2 to the first, which is just 8. F of 2 is 8 times 2 squared, and granted, order of operations say that we should really square that number first, and therefore we get 32. And f of 3 is 8 times 2 to the third. That's 8 times 8, and that's 64. Right? Whoops, and that shouldn't be 8, that should be 16. I'm like, something doesn't seem right here. Right? And again, notice what I'm saying, right? We always are starting with that, I don't want to call it base, but that original number, that y-intercept, And every time we're increasing x by 1 unit, we are multiplying then by the base that many times. I take 8, multiply it by 2 once, I have 16. Multiply it by 2 twice, 32. Multiply by 2 3 times, 64. And of course, what's happening in each of these cases, right, is we just keep multiplying by 2 to make our output larger. Now let's deal with some negative inputs. Letter C. Calculate the following without the use of your calculator. F of -1, f of -2, f of -3. And again, the way I'd really love you to be able to think about this is that in these cases, what I'm asking you to do is divide 8 by 2 once, divide 8 by 2 twice, divide 8 by 2 3 times. Regardless, why don't you go ahead and see if you can figure out what the answers are for those outputs. All right, well, let's do it. Good chance for us to review negative exponents as well. F of -1 is going to be 8 times 2 to the -1. That's 8 times 1/2, and that's 4. F of -2, 8 times 2 to the -2. That's going to be 8 times 1 over 2 squared. 8 times 1/4, and that's 2. And f of -3, 8 times 2 to the -3, 8 times 1 over 2 cubed, 8 times 1/8, which is equal to 1. And notice again, right, we start off with 8, we divide by 2 once, we get to 4, divide by 2 again, we get to 2, divide by 2 again, and we get to 1. Right? And again, that fits with exactly how we want to think about both positive exponents in letter B and negative exponents as we just saw in letter C. Now let's take a look at the graph of this function. Letter D. Use your calculator to produce an accurate sketch of the function using the window provided. Mark your y-intercept from A. All right, so what I'd like you to do is take your graphing calculator. We've done plenty of graphing in this course already. I'd like you to put this into your graphing calculator. I've given you a window. X min is -4, X max is +4. And notice the Y scale is quite large. I've got Y min at -10 and Y max at +60. So why don't you put that in and sketch a graph as well. Please make sure to mark your y-intercept from letter A. All right, well, if we put this in our graphing calculator, we use that as our window, we're going to end up getting a graph that looks like that, right? And again, it makes sense, right? As we're moving in this direction, we're taking that 8, doubling it and getting 16, doubling it again and getting 32, doubling it again and getting 64. After that, it would be 128, etc. Whereas when we go in this direction, right, we're taking the 8 and we're halving it and getting 4, taking another half, we're getting 2, another half, we're getting 1, another half, we're getting 1/2, then it would be 1/4, 1/8, 1/16, 1/32, etc. All right, now one of the things that they want you to think about a little bit in this course is what's called the end behavior of functions. And that specifically means as x goes out to infinity, what is the function doing? And as x goes to -infinity, what is the function doing? Let's take a look at letter E. Fill in the following regarding the end behavior of this exponential function. As x goes to infinity, the function f of x goes to, and as x goes to -infinity, the function of f of x goes to, right? Well, as x goes to positive infinity, it's pretty easy to see that this function is just increasing without bound. So we would say that as x goes to infinity, f of x also goes to infinity. On the other hand, a little bit trickier to think about is that as x is heading to -infinity, this thing is certainly not going down, it's not going to -infinity, but it does keep decreasing, right? Because we keep taking x and dividing it by 2 again and again and again. So the number is getting smaller and smaller and smaller and smaller, but if I take 8 and I divide it by 2 repeatedly, it's never going to go negative. In fact, as x approaches -infinity, the function is getting closer and closer to 0. We're going to eventually talk about what are called asymptotes of exponential functions, but we'll get to those in a few lessons, okay? All we need to know now is that, at least for this exponential function, as x goes to positive infinity, the function heads up to infinity, and as x goes to negative infinity, the function is heading towards 0. All right, the base effect. The behavior of simple exponential functions has a great deal to do with the value of their bases. And the base is the number that you're multiplying again and again and again by. In our last problem, the base was equal to 2. Let's take a look at exercise number 2. Given the exponential function f of x equals 16 times 0.75 to the x, answer the following questions. Letter A. What is the function's y-intercept? Well, this should be pretty simple, but if you're not sure, of course, just substitute x equals 0 in and figure it out. All right, well, it doesn't really matter that the base is equal to 0.75 here. F of 0 is going to be 16 times 0 to the 0.75 to the 0, which is equal to 16 times 1, which is equal to 16. So again, that y-intercept is sitting right there. All right, and it always will be. Now, letter B. Using your calculator, find the values of f of 1, f of 2, and f of 3. And notice this time I'm asking you to use your calculator because I'm not expecting you to do 16 times 0.75 to the third, right, without a calculator. I don't even necessarily want you to do, you could do 16 times 0.75 to the first without a calculator, but why don't you go ahead and figure out each of those values and then we'll talk about them. All right, well, let's take a look. So f of 1, that's simple enough, right? So 16 times 0.75 to the first, that ends up being the wrong sheet. So let's grab this one. That helps a little bit more. That's a nice number, 12. F of 2 is 16 times 0.75 to the second. So I'm multiplying 16 by 0.7 times 2 times. That's also a pretty nice number, 9. And f of 3, 16 times 0.75 to the third, a little bit less nice, that's still not too bad, 6.75. So when I multiply by 0.75 once, I go from 16 down to 12, 0.75 again, I go from 12 down to 9, and then 0.75 one more time from 9 down to 6.75, which leads us then to letter C. Why are the values of the output decreasing as x increases? So in the last problem, when we were multiplying by 2 again and again and again, right, the values of the output increased as x increased, but here they're decreasing. Why is that? Pause the video now and see if you can write something down. All right, well, they're decreasing because the base is less than 1. The base is less than 1. Let me make sure that really looks like the number 1. Now remember, the base is always positive, so the base is always greater than 0, all right? But when we multiply a quantity by a number between 0 and 1, 0.75, 0.5, 0.1, 0.9, right, it reduces the quantity, right? It makes it smaller. When we multiply by a number greater than 1, it produces something that is larger. And of course, when we multiply by the number 1, it doesn't change anything at all, which is kind of nice, right? So let's take a look at letter D. Using your calculator, sketch a graph of the function using the window indicated. Mark your y-intercept. So very similar to before. In fact, the y window is identical to the last one, as is the x window. So go into your calculator now and just replace the function that was in there with this new function, graph it, sketch that function, and also mark its y-intercept. All right, well, we're going to get a graph that kind of looks a little bit like that. Awesome. right? Here's our y-intercept at 0, 16, or if you just wrote down 16, that's fine, right? We also see that moving from left to right, this function is now always decreasing. And that will then allow us to answer the same question that we did before about end behavior. Let's take a look at letter E. Fill in the following regarding the end behavior of this exponential function. All right, see if you can now fill in what should go in these two blanks. All right, now it's the exact opposite of before. As x goes to infinity right now, this function is getting smaller and smaller, but never going negative, and therefore as x goes to infinity, this function is approaching 0. On the other hand, as x goes to negative infinity, out this way, the function is just simply getting larger and larger, and in fact, f of x is going to positive infinity. If you think, wow, when I look at these two exponential graphs, they almost seem like reflections of one another across the y-axis, they aren't exactly, but they're close, right? So, it basically boils down to a very simple idea: exponential function characteristics. For an exponential function that has the form y equals a times b to the x, a is its y-intercept. And the function will increase if b is greater than 1, and will decrease if b is between 0 and 1. So this is absolutely key. For most normal exponential functions, a and b are both positive numbers. A will always be the y-intercept. It will always be where the function kind of starts along the y-axis. Now b, the base, if that is greater than 1, then we'll have a function that increases because we're multiplying by a number repeatedly greater than 1. On the other hand, if b is between 0 and 1, and don't think of that as, oh, if b is a decimal or if b is a fraction. No, it's whether the number is greater than 1 or less than 1. If the number is less than 1, then we will have a decreasing exponential. All right, very, very critical. So real simple, let's take a look at exercise number 3. For each of the following exponential functions, sketch a rough graph, state and label their y-intercept, and state whether they are increasing or decreasing. All right, and when I say sketch a rough graph, I mean a rough graph. You don't even need to use your graphing calculator on here, right? Let's do letter A together, right? In letter A, we have y equals 30 times 0.95 raised to the x, okay? So what do I know about this thing? First thing I'm going to do is I'm just going to draw something that looks like this. Now I know because the base is 0.95 and it's less than 1, then this will be a decreasing exponential function. All right? The only other thing I really need to mark on this thing is its y-intercept, which I also know must be 30. So this is a decreasing exponential function. All right, I'd like you to do the same thing for letter B. All right, same song, second verse. I'm going to draw out a set of axes. All right, because my base is greater than 1 now, this is going to be an increasing exponential function. I know its y-intercept is 18. We'll write down increasing, and that's it. For right now, that's all we want to be able to do with these. We could put them in our calculator and produce far more accurate sketches, but I want you to just be able to look at an exponential function, its equation that is, be able to identify its y-intercept, 30 here, 18 here, and whether the function is increasing or decreasing. And that's all about whether or not the base is less than 1 for decreasing or greater than 1 for increasing. All right, let's wrap this thing up. Now, we probably didn't see anything today, maybe besides the description of the end behavior, that was really new in terms of exponential functions. Exponential functions always start with some number and then repeatedly multiply it or divide it by some base, depending on whether that base is greater than 1, less than 1, and whether or not the exponent is positive or negative. Exponential functions are probably the second most common function that we see in science and math, only second to linear because they're so simple, right? Start with a number and repeatedly multiply or divide it by some other number. Right? Very, very similar to linear in fact, and in fact what we'll see is that all exponential functions are also one-to-one, meaning that they are always increasing or always decreasing, therefore never having a y value repeat itself. Well, more on that later. For now, I just want to thank you for joining me for another Algebra 2 lesson by eMath Instruction. My name is Kirk Weiler, and until I see you again, keep thinking and keep solving problems.